All right, welcome. If you're a computer science student, you know the whole topic of operating systems can feel, well, like a total monster. But what if there was one simple way to think about it that could make it all just click? Well, that's exactly what we're going to do in this explainer. We're going to give you the mental model you need to crack the code on the OS and totally ace your exam. I mean, seriously, just stop and think for a second about what's happening on your machine right now. How is your game getting access to the graphics card at the same time your browser is using the network card, all without the whole thing crashing into a pile of digital chaos? The answer is one of the most brilliant pieces of software ever created. And the hero of this whole story is, you guessed it, the operating system. I want you to think of it as the ultimate traffic cop, or maybe a super efficient manager for your computer. Its entire job, really, is to prevent digital gridlock and make sure all your apps can play nicely together. So, what is it exactly? Well, an operating system, or OS, is the fundamental software that manages everything. And I mean everything. From who gets to use the CPU, to how memory is divided up, to what your keyboard and mouse are doing. It's the essential bridge that lets your software, like that game, actually talk to your physical hardware, like the graphics card. Now, right at the very heart of the OS, there's a special component called the kernel. Look, if the OS is the entire management team, the kernel is the CEO. It has privileged access, total control, and the final say on every single thing that happens. It is, without a doubt, the boss. Okay, and this right here, this is the single most important idea you need to remember to absolutely ace your exam. To make all these abstract techie concepts feel real, we're going to use one simple analogy for this entire explainer. I want you to think of the kernel as the ultimate all-powerful office manager. Everything we talk about from here on out will connect right back to this one idea. So, here's the game plan. First, we're going to see how our manager juggles all the employees and their tasks. Then we'll look at how it organizes the office space itself. Third, how it runs the company filing cabinet. After that, we'll see the official way employees have to make requests. And finally, we'll wrap it all up with a quick cheat sheet to lock it all in for your test. All right, first up, juggling tasks. The technical term for this is process management, and it's all about how our office manager, the kernel, deals with dozens, sometimes hundreds of employees all trying to get their work done at the same time. Okay, first let's nail down a super important distinction. You are definitely going to see this on your test. What's the difference between a program and a process? A program is just a file on your disk. It's a passive set of instructions, kind of like a blueprint for a job. A process, on the other hand, is that program when it's actually running. It's the active employee who's been hired to follow that blueprint and do the job. So what you're looking at here is the entire life of our little employee process, a classic exam topic called the 5-state process model. It starts as new, the moment the manager says you're hired. Then it moves to the ready state. It's at its desk, ready to go, just waiting for its turn with the CPU. Once the manager gives it the green light, it's running. If it needs to wait for something, like a file to download, it goes into the waiting state, so someone else can work. And finally, when the job's all done, it's terminated. Understanding this flow is absolutely key. So how does one process create another? Well, it has to use these formal requests we call system calls. For example, fork is basically like asking the manager, hey, hire a clone of me to help out with this job. Exec is telling the manager, okay, now give that new hire a completely different job to do. Wait tells the manager you're just going to chill until your new hire is done. And exit is simply saying, my work is finished, you can let me go now. Okay, let's move on. Now we're talking organizing space, or what's technically known as memory management. So our manager has all these employees, all these processes, but now they need a place to actually sit down and do their work. So in our office analogy, your computer's RAM is simply the office floor, and it's filled with a limited number of desks. The office manager's crucial job here is to assign a desk to every single employee or process. They have to keep a master chart tracking which desks are free and which are occupied. And just as important, when an employee is done and leaves, the manager has to make sure that desk is totally cleaned up and made available for the next person. That constant juggling act is the very core of memory management. And this? Oh, this is a perfect example of a classic problem called fragmentation. Imagine we need to bring in a big conference table that needs the space of 3 desks all lined up. Now, if you look at our office map, we have 4 free desks in total, so it should fit, right? But because those free desks are scattered in these little separate chunks, there's no single continuous space big enough for our table.
That is memory fragmentation, and it's why an OS has to use clever tricks to manage memory more efficiently.
Okay, so our employees have their tasks, they have their desk space, but to do their jobs, they need to actually get their hands on the company's records. And that brings us to file management. So, what's a file system? Well, in our office, it's just the massive, perfectly organized company filing cabinet. It gives us that logical structure we all know, folders inside of other folders. Our office manager is the one and only gatekeeper of this cabinet. They handle every single request to create a file, find a file, or delete one. And crucially, they're also the head of security, right? They control exactly who has permission to open which drawers, making sure the accounting employee can't just peek at engineering's files. So, how does a process actually ask for a file or for more desk space? Yeah, it can't just go grabbing stuff willy-nilly. That would be total chaos. Instead, there's a very specific, very formal procedure for every single request. And that procedure is called a system call. This is the only way, the one and only formal, protected way for a process to ask the kernel, our manager, for any kind of service. Just think of it like an official standardized request form. An employee fills it out, hands it to the manager, and the manager performs the task for them. This makes sure no employee can mess with resources they're not supposed to touch. Let's see how this works with our filing cabinet, for example. An employee would use specific system calls. Open is basically saying, hey manager, please go get me the Project Alpha file. Read is asking, what's on page 3 of this file? Write is, please add this new memo into the file. And close is simply, thanks, I'm done with this. You can put it back now. Every single interaction is a formal, managed request.
Whew, okay, we have covered a ton of ground. Let's lock it all in with a final super quick cheat sheet. Remember, the whole key to acing their exam is just connecting each of these technical terms back to our simple office analogy.
Here it is. The kernel, that's your office manager. A process, that's an employee who's actively doing a job. RAM, that's just the limited desk space in the office. The file system, the company's perfectly organized filing cabinet. And a system call, that's the official request form an employee has to use to ask the manager for anything. If you just remember these 5 connections, you're going to be in fantastic shape.
So at the end of the day, an OS is really just a manager, right? It sets the rules to make sure everything is fair and efficient. But as our computers get way more complex, with thousands of cores, new types of hardware, the job of this manager is getting exponentially harder. So the real question, the one I want to leave you with, is this. Now that you know the rules of the game, how would you design a better manager for the computers of tomorrow?